latitude and longitude. This is one of the theory-based areas to be tested in certificate exams. The formula of the length of an arc of a circle plays a crucial role here. So here we have a circle with center O, and here from A to O is radius, and O to B or B to O, line B is also radius. So circle with center O. The length of arc AB is equal to theta over 360 degrees times 2 pi r. The Earth is spherical in shape. Any cut or slice through it horizontally, latitude. So if you cut the sphere of the Earth, which is spherical, if you cut horizontally, you're going to have latitude. This is an hemisphere, and then this is also an hemisphere. So you're going to have lines, latitude, lines of latitude, or vertically. If you cut like this, the cut is like this. So what you're going to have lines like this and this, and also like this. So if you cut it horizontally, you're going to have lines like this part like this. So you're going to have okay, you're going to have parts like this, which comes like this, and then the other half like this. All right, that's what you're going to have. So the Earth is spherical in shape. Any cut or slice through it horizontally, that's latitude, or vertically, longitude, is circular in shape. You can use an orange to verify this. To find the distance between any 2 points on such slice, we have to use the mentioned formula above, which means we're going to use this formula, length of arc AB, or length of an arc formula, which is theta over 360 degrees times 2 pi r. All right, so now look at the diagram. This these are north, this is the south, and this is the west, is the east, this is the globe, what represents the Earth. This line of longitude, from whichever that line of longitude is measured, is known as the Greenwich Meridian, and the equator is our line of latitude from whichever other latitude is measured, or every other line of latitude is measured rather. So the measurement of any point on the latitudes, either to the east or the west, must start from the Greenwich Meridian, while that of longitude, either to south or north, must start from the equator. Any point on the Earth's surface is the intersection of latitude, longitude, like in coordinates xy. So whatever you're going to have in, let's say you have 30 degrees north and 60 degrees east. So this first part in our coordinate is just as in our xy coordinates. Our x here is the latitude and y here is the longitude. So that's the way the intersection of 2 points on the Earth's surface is measured. Latitude comes first, followed by longitude. So any point on the Earth's surface is the intersection of latitude, then longitude, like in coordinates xy. So we are going to look at great circles. Okay, we are going to look at great circles and small circles, units of measurement. Degrees and seconds are the units of measurement. Latitude is from 0 degrees to 90 degrees south or north. So either the lines of latitude are always going like this to the south, or like this to the north, because if you cut an orange horizontally, you're going to have 2 parts. So the circles formed lines of latitude. So the lines of latitude are measured from equator 0 degrees to 0 degrees to 90 degrees north, or 0 degrees to 90 degrees south, which are these lines of latitude. And then longitude, while longitude is from 0 degrees, from the Greenwich Meridian, 0 degrees to 180 degrees east. So from the Greenwich Meridian, 0 degrees, 30 degrees, 60 degrees east or west. So take note of that. These are lines of longitude and these are lines of latitude. Solution number 1. Find the angular distance between A 40 degrees north, 65 degrees east, and B 35 degrees south and 65 degrees east. So from what we're given, it shows that both A and B are on same lines of longitude, are on same line of longitude, 65 degrees east. So we'll get our north. So then this is equator. Right. So we'll call this longitude. Longitude 65 degrees east and 35 degrees south. So 35 degrees south would be like, so let's say 35 degrees south, 40 degrees north. Okay, this is not 40 degrees north and 35 degrees south. This is 35 degrees south. So this point of intersection, this is E, bring it to the equator, and then this is E. So where this, remember this longitude 65 degrees east, and this is latitude 40 degrees north. So the point of intersection is the position of, or the position of A, or where point A is located. And so also with B. B is 35 degrees south, which is the line of latitude, 35 degrees south, 65 degrees east. Longitude is 65 degrees east, and this is longitude 65 degrees east. So the point of intersection is where B is situated. So bring it to this point, and of course this is, let's call this point D. So we're going to have this shape. So our angular measurement will be 35 degrees is 35 degrees. So let's call this is A D B. So A B D is 35 degrees, and A D M D A here will be 40 degrees. Now something you notice that, okay, when we discover that A is on the northern hemisphere and B is on the southern hemisphere, so the angular distance is equal to 40 degrees plus 35 degrees, so that will give us 75 degrees. So what that implies that if the 2 points are on different hemisphere, you are going to add when you are looking for the angular distance. But if they are on the same hemisphere, you're going to subtract the smaller angular distance, the smaller angle from the bigger or larger angle. So in this case, B is on the southern hemisphere, A is on the northern hemisphere. So the angular distance between them is going to be the total, which is going to be 75 degrees. But if both of them were on either the southern hemisphere or the northern hemisphere, I'm going to subtract the smaller one from the bigger angle. So number 1 is 75 degrees. Number 2, find the angular distance between X 60 degrees north, 20 degrees west, and Y 40 degrees north, 20 degrees west. Right. So our line of longitude is 20 degrees west. Let's see, longitude 20 degrees west. So Y is 40 degrees north, and this is 40 degrees north, and these are equator, and the other part is 40 degrees 60. Okay, X is 60 degrees north, X is 60 degrees north, and Y is 40 degrees north. Is 40 degrees north. So yes, this is point X and this is point Y. So bring down sorry, the equator. So what is inclined? So we're going to have, so let's call here x, y, let's call this point C. So we have this is x, y, z. So this is the equator, measured from the equator. So from the equator to y is 40 degrees north, and from the equator to x is 60 degrees north. So since both of them are in the same hemisphere, that is the northern hemisphere, our angular distance is equal to angular distance is equal to 60 degrees minus 40 degrees, and that will give us 20 degrees. And 3. X and Y are two places on the same circle of latitude 80 degrees north. So this shows that both X and Y are on the same line of latitude. So let's call, first of all, let's use our equator. North. So latitude 80 degrees north. Okay, so now X is on longitude 79 degrees west. This is longitude 79 degrees west, and Y is on longitude 11 degrees east. Longitude 11 degrees east. So this is X and this is Y. Okay. So line is X point Y. X, Y, X, let's call this Q. XQ is 79 degrees and Y is 11 degrees. So the angular distance between X and Y is equal to, since they are the different parts of the globe, different hemispheres. This is on the western part of the globe and this is on the eastern part of the globe. We're going to add the angles together. 79 degrees plus 11 degrees, that's equal to 90 degrees. This is the angular distance. So let's look at the note that we need to get, or what we need to put at the back of our mind. Note, to find the difference in longitude when the longitudes of two places, one, are on opposite sides of the prime meridian, that is our east and west, simply add longitudes together. What that means is that if this is the globe and then this is north-south, this is the prime, so this is the Greenwich meridian from which every other lines of longitude are measured. So if a point is on X, let's say X is here, and then Y is here, so X is here, and then this is another line of longitude. So because both X and Y are on, the longitudes are on different parts of the globe, X and Y, so the angular difference will be angular difference theta. The theta is equal to, you add the angle of X, the longitude of X plus the longitude of Y, because they're on different parts of the globe. So two states are on opposite sides of the prime meridian, that is east and west. This one is X is on the west, Y is on the east, so you add together. But when both X and Y are on the same meridian, or on the same side of the meridian, that is both east or both west, you subtract the smaller longitude from the larger one. So assuming we have point C, another line of latitude here, and this is point C, so this will come here, and this, let's say these are equator, this comes here, sorry, so the x is to the equator, and this is point x. So because they are on the same side of the meridian, both x and z are on the west of the globe, you are going to subtract. So in this case, x angular difference theta is equal to the larger one. We subtract the smaller longitude from the larger longitude, which is x minus z. So when the two longitudes, one is on the when the two longitudes are on different sides of the meridian, you add to get angular difference. When they are on the same side of the meridian, either both west or both east, you subtract the smaller longitude from the larger longitude. The same principle applies to latitude, difference in latitude. So if one is here on the southern hemisphere, let's say on the same line of longitude, let's say this is K and the other is Y. So from equator to this here. So the angular difference, because since the first latitude is on the southern hemisphere and the second latitude is on the northern hemisphere, so the angular difference will be k plus y. But if both of them are on the same hemisphere, like k, and the other one is, let's say this is another line of latitude, this is m, so this will give us this. So the angular difference will become the smaller latitude, which is k minus m. Subtract the smaller latitude from the larger latitude. So take note of this. Take note of the angular difference, the principle that governs it. When the two positions are on different parts of the hemisphere, you add to get the angular difference. But when they are on the same part or the same side of the hemisphere, you subtract to get the angular difference.